day 4. Welcome to the Jamb Master Life Physics class day 4. If you're just joining us, start writing. We are in for serious work today. Get your writing materials. Get rid of all distractions. Get rid of all distractions. Get rid of all distractions. Let us get started. We are not joking today. Where's my calculator? Get your writing materials. I'll give you 1 minute to get rid of all distractions. 1 minute to get rid of all distractions. 1 minute to get rid of all distractions. Get your writing materials ready and let us get started. Get rid of all distractions. Get your writing materials ready and let us get started. If you can see the board, say, "Sir, I can see the board." If you can hear me clearly, say, "Sir, I can hear you." Sir, I can hear you. Sir, I can hear you. If you can hear me clearly, say, "Sir, I can hear you." Sir, I can hear you. Sir, I can hear you. If you can hear me clearly, say, "Sir, I can hear you." Sir, I can hear you. If you can hear me clearly, sir, I can hear you. If you can see the board, say, "Sir, I can see the board." Get your writing materials. Let us get started. 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 Get your writing materials. I'm waiting for you. Let us start. Drop your comment as soon as you come in. Drop your comments. Drop your comment as soon as you come in. As soon as you come in, drop your comments. As soon as you come in, drop your comments. You are welcome to the Jamb Master Life Physics class. You are welcome to the Jamb Master Life Physics class. You are welcome to the Jamb Master Life Physics class. Edafe Wisdom, I see you. Michael Kosochuku, I see you. Edafe, I see you. Yes. Others have gone to sleep, but you stayed back, you want to learn. Others have gone to sleep, but you stayed back, you want to learn. Others have gone to sleep, but you stayed back, you want to learn. That is the energy. Others have gone to sleep, but you stayed back, you want to learn. Get your writing materials, let us get started. 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 We are not yet to do Kelvin Samuel, welcome. Miracle Adeyemo, welcome. Welcome. Class, we're starting with temperature. We'll take it easy first. I believe one way or another, every student here knows this already. Class, temperature. Yes, don't forget our usual style. Before we start a class, you are going to make a commitment. Before we start today's class, you are going to make a commitment. I will not leave till the end. You are going to make a commitment. I will not leave till the end. You are going to make a commitment. Type in the comment section. I will not leave till the end. I will not leave till the end. Let us make that commitment. Secondly, take this phone number down. Should in case the class is going on, and at a point the whole class can no longer hear me. And cannot see the board. Please call this number. That is when the whole class cannot hear me and cannot see the board. It's a general network situation. Please don't call this number if it's only a personal issue with your network. Before you call this number, confirm that everybody cannot hear and cannot see. Type a comment in the comment section and check. Ask others. Guys, can you hear? Can you see? If 2, 3, 4, 5, 6, 7 people say they cannot hear, they cannot see, it therefore means the general problem. What I will then do is to end the live and fix another live immediately. I will end the live and fix another live immediately so that we can continue. The good thing is that wherever the network starts affecting, every video we have done before will be saved. So we have not lost it. Every video we have done before will be saved, we have not lost it. Also, for new students just joining us, please take notes that this is day 4 of physics, Jamb Master Life Physics. We couldn't have been waiting for you. Jamb is too close. There is no serious tutorial you will join that is just starting now. There is no serious tutorial you will join that is just starting now. It is not possible. Are we together? But the good thing you should ask is that I hope you have records of all your classes you have done. Yes, every class we have is recorded. So any class you missed, we are just to send you the link to the video. You can catch up during the daytime before the night class. Our class hold at night. Before our next class tomorrow night, I will send you videos of everything we have done in physics. I thought personally you say it. If you're an art student, I will send you for your art courses. If you're a commercial student, I will send you for your commercial courses. So no cause for alarm. No cause for alarm. Everything we have done in physics, I'll send to you. The things we have done in chemistry before you join, I'll send to you. Everything in all the subjects you have done, I'll send to you so you can catch up. But today is a new topic and we have not taught anybody these topics. So it's a chance to learn something new with us. It is a chance to learn something new with us. Let us get the ball rolling. Before I start for the final time, final check. If you can hear me, say I can hear you from the board, sir. Type it like that. I can hear you from the board, sir. And I can see the board clearly. I can see the board clearly and I can hear you from the board, sir. One final check and we start. One final check and we start. One final check and we start. I can hear you clearly, sir, and I can see the board. I can hear you clearly, sir, and I can see the board. I like the energy in this set. I can hear you clearly, sir, and I can see the board. I will not live to the end. Someone said, best teacher ever. Thank you. Someone said, I will not live to the end. I will not live to the end. I will not live to the end. Yes, you are all welcome. You are all welcome. Someone said, I just prayed I will not sleep off for you. You will not sleep off. You will not sleep off. Temperature is the degree of hotness or coldness of a body. Temperature is the degree of hotness or coldness of a body. It's a measure of how hot or cold a body is. Class, temperature as a unit in degrees Celsius, as unit degree Fahrenheit, and as unit Kelvin. So temperature can measure in degrees Celsius or degrees centigrade, degree Fahrenheit, and Kelvin. Notice that the Kelvin does not have degree, just Kelvin, just Kelvin. So this is degrees Celsius, degree Fahrenheit, and Kelvin. Class, as simple as this looks, you could be asked in the exam to convert the temperature of a body from one unit to the other. We are starting with something very easy. Everybody knows this, Abi? Good. Class, we know that to convert from degrees Celsius to Kelvin, the conversion unit is degrees Celsius plus 273 equals to Kelvin. But to convert from degrees Celsius to degree Fahrenheit, the conversion unit is degrees Celsius equals to 5/9 degree Fahrenheit minus 32. Class, this is the conversion from degree Celsius to degree Fahrenheit. Class, because your Jamb is an objective exam, nobody wants to see your solving. They just want to see that you got the correct answer. Class, be smart enough to know how to convert very fast. Be smart enough to know how to convert very fast. Be smart enough to know how to convert very fast. Class, if someone gives you a temperature of 30 degrees Celsius and you have to go to Kelvin, class, don't need to apply any formula. Even if there's a formula, just add 273 to this value, plus 273, and you have gone to Kelvin. That will give you 303 Kelvin. That will give you 303 Kelvin. That will give you 303 Kelvin. But class, if someone gives you 500 Kelvin and you have to convert to degrees Celsius, class, you're going to subtract 273. So 500 minus 273, that will give you 227. 227 degrees Celsius. Class, so to cut the long story short, from degrees Celsius to Kelvin, add 273. But from Kelvin to degrees Celsius, subtract 273. But if they now give you from degrees Celsius to Fahrenheit, that's when you cannot apply the formula. Class, I don't have a shortcut for that. You have to apply the formula. You have to apply the formula. You have to apply the formula. Let us go, let us go, let us go. Let us go, let us go, let us go. Class, if you are given 30 degrees Celsius and you have to convert to degree Fahrenheit, you are given 30 degrees Celsius and you have to convert to degree Fahrenheit, what will you do? Using this formula, degrees Celsius is 30, right? Equals to 5. Let's use 5 to expand the bracket. 5 times F, 5F. 5 times minus 32 minus 160 divided by 9. Let us cross multiply. So we have 5F minus 160 equals 30 times 9 is 270. 5F must be equal to 270. When minus 160 comes to this side, it becomes plus 160. 5F equals 270 plus 160 looks like 510. Is this 510 or 410? Okay, 430. Sorry, 430. It's not time to divide both sides by 5. So that 430 divided by 5. Will give us 86 class. So our degree Fahrenheit 86 degree Fahrenheit. We are just converting from degree Celsius to degree Fahrenheit. 86 degree Fahrenheit. 86 degree Fahrenheit. 86 degree Fahrenheit. If you are following, say sir, I am following. If you are following, say sir, I am following. If you are following, say sir, I am following. If you are following, say I am following, sir. I am following, sir. If you are following, say I am following, sir. If you are following, say sir, I am following, sir. Omowumi, well done. Kelvin Samuel, well done. Lima done. Ifechuku Faustina, well done, well done. Class, what if they gave you 80 degree Fahrenheit and say go to Celsius? Convert 80 degree Fahrenheit to degrees Celsius. Convert 80 degree Fahrenheit to degrees Celsius. Class, this time around you are giving Fahrenheit, you are not giving Celsius. In the first example I gave you, are giving Celsius, you are not giving Fahrenheit. 80 degree Fahrenheit means anywhere you see F, put 80. So degrees Celsius will be equal to 5 over 9, 80 minus 32. Degrees Celsius equals to 5 over 9, 80 minus 32. So degrees Celsius equals to 5 over 9, 80 minus 32 should give us 48. 80 minus 32 should give us 48. So that 48 times 5 should give us 240. Now 240 divided by 9 should give us 26.66 degrees Celsius. Class, this is degree Fahrenheit to degree Celsius. This is degree Celsius to degree Fahrenheit. Class, what if you have to convert from degree Fahrenheit straight to Kelvin? If you have to convert this guy to Kelvin instead of degree Celsius, what would you have done? You would have first passed through degree Celsius, convert him to degree Celsius first. From degree Celsius, you now go to Kelvin. Who remembers? How do you go from degree Celsius to Kelvin? Who remembers? Just add 273. I told you the shortcut. From degree Celsius to Kelvin, add 273. What am I saying in essence? If you are given 80 degree Fahrenheit and say go to Kelvin, first go to degree Celsius, you get 26.66 degrees Celsius. From degree Celsius, you can now go to Kelvin by adding 273. Please take notes. I'll give one more question under this conversion and then we'll move to the next topic. If you're just joining us and you feel like we are too fast, please remember and record that this is an online class. In an online class, the student has the power to rewind the video over and over again. There's nothing like we don't understand in Jamb Master online class. Ask those that have been here. There's nothing like I don't understand. There's nothing like you are too fast because you have the power to slow down the video. YouTube has given you the power. Go to your settings. You can slow down the way I'm teaching this class now. You can reduce it to the smallest speed. Yes. Ask someone to show you cannot do it. Go to the settings in your phone. You can reduce the way I'm teaching it in your phone. So in an online class, nobody can say I don't understand. Nobody can say I am too fast. If you don't understand, just simply rewind the video and watch again. If I'm too fast, slow down the speed of your own watching. Everybody must not watch with the same speed. Are we together? That's the power of an online class. Just slow down the speed. If I'm too fast, slow down the speed. But we know Jamb is too close. There are a lot of things to cover. If I'm not fast for you, you should be angry. If I'm not fast by now, you should be angry with me. So I don't want us to pass. If I'm not fast, you should be angry with me. Now let's go. Let us go to heat energy and heat transfer. Heat energy and heat transfer. Class, Jamb loves heat transfer a lot. Your conduction, your convection, your radiation. Many students don't really understand between conduction, convection, and radiation. I know this is not what you are thinking. You are thinking about all the big Jamb topics. There are some topics that you neglect that Jamb doesn't joke with. I am picking this topic because I'm the Jamb master and I know the topics that Jamb loves a lot. So follow me, you will clear your Jamb. Heat energy and heat transfer. Heat energy and heat transfer. Class, heat energy is also known as thermal energy. Class, anytime you hear thermal, it means heat. And class, this is total energy stored in a body. Heat energy is the total energy that is stored in a body. Class, I must inform you that when there's an increase in temperature of a body, expect an increase in the heat energy of the body. Increase in temperature increases what? The heat energy. Increase in temperature increases heat energy. Increase in temperature increases heat energy. And note, class, that heat usually flows. Heat usually flows from a high temperature object. It usually flows from a high temperature object or from a high temperature body. In bracket, you can put hot. High temperature means you are hot. To a low temperature body. Please, a general rule of heat, class. The higher the temperature, the higher the heat energy. The lower the temperature, the lower the heat energy. Let us look at some effects. What does heat cause on the body? Effect of heat. What are the effects that heat, when you apply heat to a body, what are the things you will notice? What are the things you will notice when you apply heat on a body? Class, thermal physics is one major aspect of physics. Everything other thermal physics will be done today. Your thermal expansion, that's linear expansivity, area expansivity, and volume expansivity. Another name for volume expansivity is called what? Cubic expansivity. Your heat capacity and your specific heat capacity, very important. Then your latent heat of fusion, your latent heat of vaporization. We're going to look at what is latent. Latent means hidden. Latent means hidden. There is no way Jamb will set 40 questions. They will not bring something from this place. Not possible. That they will not set radiation. They will not set convection, conduction. They will not set linear expansivity. They will not set area expansivity. Volume expansivity is not possible. Heat capacity, specific heat capacity, radiation is not possible. It's not. So this thermal physics. Your examiner is not allowed to set Jamb question without going through thermal. Thermal is one major part. There are 5 pillars of physics. Thermal physics, electricity physics, gravitational physics, waves and optical physics. Waves. You cannot write Jamb, we don't see waves. I think tomorrow is waves, right? We're doing waves. Everything about waves tomorrow. Then Sunday is electricity. Everything about electricity and magnetism Sunday. So you cannot, if there's no way you finish these topics and you not see them in Jamb, it's not possible. We have done motion, right? Motion must come out in Jamb. We have done work energy and power, right? Machines must come out in. We have done then I also owe you some topics. That's equilibrium of forces, right? Principle of moment. I will give you. I'm owing you. It's been I even said I'm taking accountability. I will give it to you. Don't worry yourself. Now let's go. Effect of heat. 1. Let me dictate so can be fast. 1 is change in temperature. Change in temperature. If you are still with me, let me know. Change in temperature. Change in temperature. Change in temperature. Change in temperature. One of the effects of heat is change in temperature. Class, it usually causes a change in temperature of a body. 2 is change of state, class. It can cause a body to change from solid to liquid, class. If you apply it to a solid, it can change to liquid. If you keep applying it on liquid, it can change to gas. So, class, it can change what the state of a body from one form to another. It can change the state of a body from one form to another. Effect of it is expansion. Class, application of heat causes expansion of a body. That's what we're going to learn in thermal expansion. Thermal expansion is the expansion of a body due to application of heat. Class, another property is change in physical properties. Change in physical properties. Application of heat can cause a change in the physical property of a body. Class ATC. Class, there's a part of this course we should have done, which is gas laws. But because we have already done gas laws in chemistry, we don't need to do gas laws here again. Because we have already done gas laws in chemistry, We don't need to do gas laws again. So I'll move away from gas law and go to heat transfer. Heat transfer. This is how we make progress gradually. I finished my first topic. This second topic is not long. Let's go to heat transfer. This is how I'm making progress gradually. Heat transfer. I'm going to dictate here so we can be fast. I am going to dictate here so that we can be fast. Heat transfer is the process whereby one body receives heat from another, or one part of a body receives heat from another part of the same body. I'll come again. Heat transfer is the process whereby one body receives heat from another, or one part of a body receives heat from another part of the same body. Note, heat transfer can take place in three ways. Heat transfer can take place in three ways. Heat transfer can take place in three ways. One is by conduction. Now let's define conduction at once. Conduction is the process by which heat energy is transferred through a body with the aid of molecules vibrating about their fixed positions and the average positions of the molecules remaining the same. I'll come again. Conduction is the process by which heat energy Conduction is the process by which heat energy is transferred through a body with the aid of molecules. With the aid of molecules. Vibrating about their fixed positions. Class, if they ask you the method of heat transfer that requires vibration is conduction. The method of heat transfer that requires vibration is what? Conduction. Class, conduction is very peculiar with solids. Conduction is very peculiar with solids. Convection is the second method of heat transfer. Convection is the process by which heat is transferred in a fluid. What is a fluid? Liquid or gas? By the actual movement of the heated fluid from the hotter to the colder parts. Class, are you aware when you are boiling your water in your kettle? It's not all the molecules of water that catches the heat at once. Some parts get hot and start transferring until the whole water gets hot. Convection is very popular in fluid, liquid or gas. Actual movement of the heated fluid from the hotter to the what? Colder parts. That is convection. Make sure you're writing, make sure you're writing. Make sure you're writing, make sure you're writing. Example of convection is in the land and sea breeze. Note that sea breeze occurs during the day and land breeze occurs during the night. You could be asked in the exam. Sea breeze occurs during the day, the breeze from the sea occurs during the day, land breeze occurs during the night. So, land and sea breeze are example of what? Convection. Two examples of convection is in ventilation. Class, are you aware that your air conditioner, your AC, uses the principle of convection? We have ventilation. Two, we have cooling of car engines. Ventilation, cooling of car engines. Ventilation, cooling of car engines. This is application of convection. Let us look at radiation. Radiation. The third method of heat transfer. Class, we are making good progress. Is the process by which heat is transferred from hotter to cooler place. Without heating of the intervening medium. Without heating of the intervening medium. Radiation is the process by which heat is transferred from hotter to cooler place without heating of the intervening medium. Class, if you ask in the exam which method of heat transfer does not require a material medium, is radiation. Does not require a material medium, does not require a material medium. Class, make sure you don't underrate any topic. Class, a very good example of application of radiation is how the heat from the sun reaches the earth. How does the heat from the sun reaches the earth? Is by process of radiation. Please take note. Heat from the sun to the earth happens by what? Radiation. Radiation. Class, if you are following me, let me know. Let me know. Let me know if you are still there. Let me know. Who is here with me? Who is here with me? Good. I will not live to the end. I will not live to the end. I will not live to the end. Let's go to thermal expansion. Thermal expansion. Thermal expansion. Write down thermal expansion. Class, don't forget, the expansion is one of the things we notice when an object increases, when the heat is applied to an object. When it is applied to an object, expansion is one of the things we notice, right? Class, there are three types of expansion that an object can experience. Class, the first one is called linear expansion. So let's call it linear expansivity. Let's call it linear expansivity. And mathematically, you have the symbol alpha. This is the increase in length. Linear expansivity is increase in length per unit length per degree rise in temperature. Increase in length per unit length per degree rise in temperature. Class, mathematically, alpha, which is the symbol for linear expansivity. Alpha is the symbol for linear expansivity. Class, is the increase in length. Class, L2 minus L1. Class, before an object is expanded, it has an initial length L1, just like we did in elasticity yesterday. After expansion occurs, it increases to L2. The increase in length is L2 minus L1, that's the final length minus the initial length. So increase in length per unit length per degree rise in temperature. What's the rise in temperature? Final temperature minus the initial temperature. The rise in the temperature of a body is the final minus the initial. This is linear expansivity. So a body can expand in three ways. One is linear. That's when only the length increase is linear expansion. Two is area expansivity. This is beta. Class, when defining area expansivity, just increase in, instead of length, you say increase in area. Increase in what? Area. Per unit area. Per degree rise in temperature. Per degree rise in temperature, this area expansivity. Increase in area per unit area per degree rise in temperature, A2 minus A1 all over A1 into bracket theta 2 minus theta 1. And the last one is cubic expansion. Cubic, also known as volume expansion. I think your guess is as good as mine. Increase in volume. Because symbol for cubic is gamma. Increase in volume per unit volume per degree rise in temperature. So we have alpha for linear expansivity, beta for area expansivity, and gamma for volume expansivity. Class, I'm sure that you have been taught this one way or the other in secondary school. Whether you remember or not, you have been taught this. But when the problem lies when Jamb now start bringing their tricky questions, that's the problem is. You cannot tell me they have not heard of expansivity before. The problem is when Jamb brings their question. Have you noticed the examples are usually very simple? Teacher will see a simple thing and give simple example. When the exam comes, they now bring another thing. That's what the problem is. Most students actually understand some of this thing, but the problem is when they get to exam, what the mistake you are making is that you're expecting the examiner to set the question the way he set it in the exam. Many of you read, you understand, yes, you do the exam and you go and relax. You do not go to the exam question to go and look for how the examiner is setting question on that topic in the exam. There's a very big difference between example given in your textbook and how the examiner will test you in the main exam. This is why past exam question is very important. And this is why all our students have their past exam question. If you have finished registering with us, you are given a Jamb Master past exam question. I hope you are using that past question. Make sure from now till Jamb, in case you are just joining us or you have not heard of this before, all our students, we are on a challenge. Apart from this normal 30 days challenge, we are on a challenge to solve at least 2 years of Jamb past question every day. Class, every day you must finish 2 years of Jamb past question. Class, we can have 300 students learning with us. Not everybody will get 300 over 400. You guys can be 300 in my class, but not everybody will get 300 over 400. Class, I've taught Jamb students before, so people still failed because they did not follow my instruction. Class, I'm not a magician, I'm not in your house. I don't know what you are doing during the day. How can I control your results? I can only do my own part. Show up at this day 4. I've been teaching day 1, day 2, day 3, this day 4. I've been showing up, I've done my own part. But you have your own part to play, class. A tutorial will not just perform magic in your brain. You have to want it for yourself. Class, I cannot want it for you. You have to want it for yourself. Look at the message I reminded you today. Show that I care, I want you to pass. You are in my mind every day, I want you to pass. But if you pass, I'll be happy. I don't want to see you in my Jamb class next year. So please, if you have been pressing TikTok, in case you just joined us, we have all deleted our TikTok. Please, if you have deleted your TikTok, type in the comment section, sir, I have deleted my TikTok. I have not opened TikTok since you said that thing. If you have deleted your TikTok, say, sir, I have deleted my TikTok. If you have not deleted your TikTok, class, you can still delete it. It's not too late. Don't let Jamb catch you on TikTok playing and watching skits. Your exam is too close for TikTok. After Jamb, you have enough time to press TikTok till post-UTME. Because we also organize a serious post-UTME to help you. We don't just leave you after Jamb. We organize another serious post-UTME class. I follow my students till the admission. I follow my students till the admission. But if you don't follow my instruction, you cannot pass. This thing I'm teaching alone will not be enough. You have to want it. You have to want it yourself. If you want it, you will follow my instructions. You will read every day. You are going to do what? You're going to do 2 years of Jamb past question every day till from now till Jamb. What is the importance of doing Jamb past question? The more you are solving different years of Jamb past question, the more you are gaining experience. Someone that has solved 20 years of Jamb past question, you cannot compare that person with someone that has not opened the Jamb past question. Class, Jamb has asked their question in the same language. Someone that has opened the Jamb past question, before you finish reading one question, he already knows where the question is going to. But you have to read to the end. Class, they give you a question in your Jamb, and you have to read it like 2-3 times before you can answer it. It means you are slow. And Jamb is speed. Exam is speed. I hope I'm not wasting your time. I can teach you physics and go, but I have to talk to you sometimes. I can teach you physics, I know physics, I can teach it and go. The teachers have been teaching you from SS1, SS2, SS3. Some of you need someone to talk to you, not just teaching. You have been learning physics, you need to go to secondary school. They have been teaching you, right? What is the problem? What is the problem? Someone needs to talk to you. Drop that TikTok, drop that WhatsApp, drop that Snapchat, drop that Call of Duty, drop that Call of Duty. Drop it. Drop that Snapchat, drop that WhatsApp status. Class, you need absolute focus if you are going to score high in Jamb. You want to be a medical doctor and you cannot sacrifice TikTok. How will you treat patients? You want to be a nurse and you cannot sacrifice Facebook. How will you be treating patients? I have many of my students that finish from university and nurse, doctors. They don't have time to press TikTok. They are always on call. You say you want to be a nurse, but you can't leave TikTok alone. Okay, prove to me that you want to get nursing. Prove to God that you want to get nursing. Delete your TikTok first. Delete your TikTok to show that I really want this thing, I can delete it. I want to be a nurse. I want to be a medical doctor. I want to be an engineer. I want to be a pharmacist. I hope I'm not wasting your time. I hope nobody says I teach now. I hope I'm giving you facts. Because we can be teaching and go. And if I don't talk to you sometimes, you'll still be lazy. You will not read. After this slide, go and read. Go and jack your past question. Burn the midnight candle. I want to post your result next year. I want to post your result next year. I want people to doubt your result. Say it's a lie. So it's not possible. You know, people doubt my students' result. I post some people are doubting it's a lie. I say go and confirm it anywhere. Say it's a lie. I want people to doubt your result next year. Class, after today, if you are still on TikTok, if you open TikTok from now to your Jamb, then you are not serious. If you open TikTok from now to your TikTok is not paying you, leave TikTok alone. Except you're a big celebrity and TikTok is paying you, no problem. Class, are we together? I think I've said enough. I think this cannot be overemphasized. I think I've said it as it is. I've said it as it is. Let us move forward. Let us move forward. Class, let us finish everything, then I will now take questions. Let me go to its capacity and specific capacity, then we'll take questions for everything at once. Let me go to its capacity and specific its capacity, then we'll take questions for everything at once. Its capacity. And specific its capacity. I hope I wasn't talking to myself. Before I teach, let me see. Are you still with me? I hope I wasn't talking to myself. Are you still with me? I hope I was not talking to myself. Are you still with me? I hope I'm not talking to myself. Are you still with me? I hope I'm not talking to myself. Are you still with me? Say, sir, I am with you. Sir, thank you for warming us up. Thank you for gingering us. We must pass this Jamb. I want you to pass. I want you to pass. I want you to pass. Class, something I forgot Jamb used to ask. Theoretical question. Which of the following is not a consequence of expansion? Which of the following is not a consequence of expansion? Class, what are the consequences of expansion? Number one, we have the bimetallic strip. There are some funny questions that Jamb asks. You'll be wondering, where is this thing in my physics syllabus? You'll be thinking in your test, where is this thing in my test? Where could I have read this thing? Some funny topics that you don't know where to read it from. Bimetallic strip, which of the following is not a consequence of its expansion? Consequences of expansion, bimetallic strip. 2. Expansion in bridges. Expansion in bridges. 3. Expansion in railway lines. 4. Sagging of electronic transmission. Sagging of electric transmission. Class, I hope you are writing. I hope you are writing. Class, you cannot fail. Class, you cannot fail. You cannot fail. You cannot fail. Have I told you my name? My name is Success. Class, my name is Success. Success and failure do not mix. Success and failure do not mix. My name is Success, so I cannot even allow you to fail. My name is Success, you cannot fail. Success and failure have nothing in common. Are you done writing? Are you done writing? Each capacity of a body, each capacity of a body is the quantity of heat required to raise the temperature of that body by 1 Kelvin or 1 degree Celsius. The quantity of heat required to raise the temperature of the body by 1 Kelvin or 1 degree Celsius. Now, what is specific heat capacity? Is the quantity of heat required to raise the temperature of a unit mass of that body by 1 Kelvin or 1 degree Celsius. Class, mathematically, its capacity is represented in the big C, while specific capacity is small c. Class, the relationship between the big C and the small c is that big C equals to m times small c. Its capacity equals to mass times what specific its capacity. Please take notes. Why its capacity is joules per Kelvin, specific capacity is joules per kilogram per Kelvin. Class, its capacity of a body is quantity of it required to raise the temperature of that body, to raise the whole temperature of the body, the full body, by 1 Kelvin or 1 degree Celsius. So it is quantity of heat which is in joules divided by Kelvin. Class, always convert to Kelvin. If your temperature is given in degree Celsius, convert to Kelvin. But class, specific capacity is the quantity of it required to raise the temperature of not just the full body, but every mass, every unit mass of the body. Imagine dividing the body into 1 unit, 1 unit, 1 unit, 1, 1, 1, 1, 1. The amount of heat is required to raise the temperature of every unit of that body is specific heat capacity. That's why it's called specific. That means specific inside the body. Are we following? Class, generally it is known that the quantity of heat stored in a body, that the quantity of heat lost or gained by body, is the heat capacity times the change in temperature of the body. What is change in temperature? That is final temperature minus initial temperature. Plus the quantity of heat lost or gained by body. The quantity of heat lost or gained by body is the heat capacity, big C. The quantity of heat lost or gained by body is the heat capacity, big C, times change in temperature is the heat capacity, big C, times change in temperature. The quantity of heat lost or gained by a body, Q, is the big C times change in temperature. What is change in temperature? Theta 2 minus theta 1. But don't forget that big C is m times small c. Big C is m times small c. Let's replace big C with what? M times small. What we have? Q equals to m times small c, theta 2 minus theta 1. So this is the formula we use to calculate the quantity of heat lost or gained by a body. This is the formula you will use to calculate the quantity of heat lost or gained by a body. Class, it is time to start taking questions. Let us go for Jamb standard questions. We are done with our topics for today. Let us take Jamb standard questions and proceed. Let us take Jamb standard questions and proceed. Let us take Jamb standard questions and proceed. So I'm with my material there that gives me exam questions on each topic, topic by topic. My material is here that gives me exam question topic by topic. Where is my expansivity page? What page are you? Expansivity. Show yourself. Expansivity, what page are you? Page 54. Page 54. Let's take some Jamb question on expansivity. The length of a side of a metallic cube at 20 degrees Celsius is 5.0 centimeter. Given that the linear expansivity of the metal is 4.0 times 10 raised to the minus 5 per Kelvin. Find the volume of the cube. At 120 degrees Celsius. Class, look at this Jamb question now. It's obvious that this is not as simple as when I was teaching it. Examples usually look very simple. Class, when the teacher is teaching you, it looks simple until they start giving you exam question. Every topic looks simple until they bring exam question. And class, you don't need to be surprised because your examiner was paid to confuse you. If all your exam questions are straightforward, then your examiner is doing a very bad job. I'll say this one more time. If all your exam questions are straightforward, then your examiner is doing a very bad job. So anytime you read a topic, don't be comfortable with just the norm, the examples. Think outside the box. Think like an examiner. If I'm an examiner, will I bring this simple topic? Would I just set it so simple that everybody will pass now? They are setting an exam to differentiate the best, right, from the rest. So they have to make it tough. So don't be angry that your exam is tough. It's the game. Just play the game. Think like the examiner and you pass your Jamb. Anytime you finish a topic, don't stop at example. Go to Jamb past question. Take all questions on that topic. If you are following my instruction in this class, I will post your result next year, definitely. I will post your result. You will see it live. Remember I told you, if you are following my instruction, you deleted your TikTok. You deleted your TikTok. And you're following my, you are doing your Jamb past question every day. 2 years every day. And you don't pass Jamb. Come and tell me why. And you are reading dangerously, burning the midnight candle. You pass your Jamb. You pass your Jamb. You don't just stop at example. Take difficult questions. Go to your Jamb question. Take difficult questions. Take difficult questions. Don't be comfortable. Take difficult questions. You are going for a big course. You are going for a big course. Medicine and surgery. Nursing. You need to think outside the box. Engineering. Pharmacy. Computer science. Biochemistry. Think outside the box. Physiotherapy. Architecture. Medical laboratory science. Radiography. Think outside the box. Physiotherapy. Think outside the box. Public health. Think outside the box. Physiology. Anatomy. Think outside the box. Class, the length of the side of a metallic cube at 20 degrees Celsius, so initial temperature is 20 degrees Celsius, is 5.0 centimeter. The length L1 is 5.0 centimeter. Given that the linear expansivity of the metal alpha is 4.0 times 10 raised to the minus 5 per Kelvin. Find the volume of the cube at class. Final temperature is what? 120 degrees Celsius. Find the volume of the cube. Class, we're looking for V2. But they give us L1. Class, by giving you one side of the cube, are you aware that the volume of a cube V1 is 5 times 5 times 5? Volume of a cube is L cube. This length multiplied raised to power 3. The volume of a cube is L raised to power 3, class. The volume of a cube is L raised to power 3. Note that when I was teaching this topic, I did not tell you that something like this will come out. I just thought to give you the formula and I left it. That's what made many students fail. They know it, but exam will not set it exactly like that. When I was teaching this topic, I did not tell you this kind of thing will happen, but it's happening. They're asking you to find volume, but they're giving you linear expansivity. Meanwhile, this volume means that you're dealing with a cubic expansion. Because they say find the volume of the cube at 120 degrees Celsius. Class, you must change this L1 to volume. Volume of the cube is L times L times L. 5 times 5 times 5 is 125 centimeter cube. We have gotten V1. Class, another thing we must change is that this alpha, you cannot use alpha to solve cubic expansion. What's the name given to cubic expansivity? Gamma. But class, it's interesting to know that gamma, cubic expansivity, is 3 times linear expansivity. So to get the coefficient of cubic expansivity, we just need to multiply the coefficient of linear expansivity by 3. Multiply the coefficient of linear expansivity by 3. 3 times 4.0 times 10 raised to minus 5. That will give you 12 times 10 raised to minus 5. In standard form, let this go back and become 1.2 times 10 raised to minus 4. Well, this is the coefficient of cubic expansion. Now that we have the coefficient of cubic expansion, don't forget that the coefficient of cubic expansion is increase in volume per unit volume by degree rise in temperature theta 2 minus theta 1. Class, you don't need to convert your temperature to Kelvin because even if you have 273 here and you have 273 here, the difference between two of them will still be the same. No need to convert your temperature to Kelvin in expansivity. Class, we are looking for V2, so we need to make V2 set the formula. Class, I don't have to derive, I can derive the V2 for you, but let me just give you the formula so you can be fast. Class, the formula for V2. So if you cross multiply here, you have V2 minus V1 equals to gamma times V1 times theta 2 minus theta 1. Making V2 set the formula, you have V2 equals to gamma V1 theta 2 minus theta 1. When minus V1 comes to this side, it becomes plus V1. Class, we have V1 here, we have V1, you can factorize. So V2 equals to V1 into bracket gamma theta 2 minus theta 1 plus 1. You can remove V1 from here, you have just 1. Class, this is the formula for V2. If ever you have to find L2, if it was linear expansivity, L2 is L1. What do we use for linear? Alpha instead of gamma. Alpha theta 2 minus theta 1 plus 1. If you have to find A2, area expansion, A1, because I can teach you volume now, you're going to bring area and you'll be lost. So I must teach you everything. Beta theta 2 minus theta 1 plus 1. But our focus is on V2, don't forget. Remember, your exam is objective. Nobody will ask you to derive this in the exam. Just know this formula. Nobody will ask you to derive this in the exam. Because this V2 minus V1 means change in volume. They could as well ask you to find the change in volume of a substance. So you put change in V. Instead of V2 minus V1, just put change in V. Now let us solve. I believe everybody has the question now, so we can solve. Let me clean this and solve here. Notice how physics is very fast because physics does not have much stories. Calculation, theories, move forward. Give theories, explain small, give calculation, solve question. Physics does not have much stories like chemistry. Notice how fast we are finishing physics because it doesn't have much stories. Just give the calculation, explain with questions, and move forward. No time to waste. I'm almost done. Now, so V2, let's solve now. We're using V2 equals to V1. Who is V1? 125 into bracket. Who is gamma? V1 is 125. Into bracket gamma, who is gamma? 1.2 times 10 raised to minus 4. Gamma, right? Into bracket theta 2 minus theta 1. Which theta 2? 120 minus which theta 1? 20 plus 1. This is going to give you 125. 1.2 times 10 raised to minus 4. 120 minus 20 is 100 plus 1. 125. 1.2 times 10 raised to minus 4 times 100 will give you 1.2 times 10 raised to minus 2 plus 1. This guy times 100, we will change this to minus 2. You have to be smart in your exam. Not everything is function calculator, be good in maths more. Next week we are taking biology, literature and mathematics. Next week is biology, literature and maths. Next week challenge is biology, literature and maths. Take notes. Next week is biology, literature and maths. Initially it was biology, literature and economics. But now it's biology, literature and maths. Please take biology, literature and maths. We are going to have 3 different groups. There will be a biology teacher for this course, there will be a literature teacher for this course, and there will be a math teacher for this course. There will be 3 different groups. I will open these groups on Sunday. If you are fully paid, you join. If you are fully paid, you join the one you are offering. Biology, literature and maths. Let's keep going. 1 to 5. Let me now use my calculator. 1 to 5 times 1.2 gives you 150 times 10 raised to minus. What is 150 times 10 to minus 2? 1, 2. 1.5 plus 1. What is 1.5 plus 1? 2.5. Our V2 is 2.5 centimeter cube. Our V2 is 2.5 centimeter cube. Our V2 is 2.5 centimeter cube. Why do I feel like there's something wrong somewhere? Where's our V1? 125. 1.2 times 10 raised to minus 4. Change in temperature is 100 plus 1. Was this change to meter? Okay. Class, we made a mistake. We have made a mistake in our solving. Class, we should have resolved everybody in this bracket. We should have resolved everybody in this bracket before bringing in 1 to 5. So this is 1.2 times 10 raised to minus 4 is times 100. Should give you 1.2 times 10 raised to minus 2 plus 1. Then you now multiply it by 1 to 5. 1.2 times 10 raised to minus 2 plus 1. What is 1.2 times 10 raised to minus 2? It's 0.012 plus 1. That will give you 1.012. So 1 to 5 times 1.012 will now give you 126.5. Who can tell me how I knew we're wrong? Class, our initial volume V1 is 125. I should not be getting a lesser volume because there was an increase in temperature from 20 to 100. So from 20 to 120. When there's an increase in temperature, expect an increase in volume. When there's a decrease in temperature, expect a decrease in volume. When there's an increase in temperature, expect an increase in volume. When there's a decrease in temperature, expect a decrease in volume. Please take notes. Please take notes. Please, permit me to clean the board. It's almost 11. Permit me to clean the board. And then I'll take another question. Don't forget, next week is biology, literature, and mathematics. Biology, literature, and mathematics. A thin aluminium plate has a surface area of 1,500 meters square at 20 degrees Celsius. What will be its surface area? When it is cooled to minus 20. Take clearness per liter of aluminium to be 2.5 times 10 raised to minus 5 per Kelvin. 2.5 times 10 raised to minus 5 per Kelvin. Take down the question. Take down the question. Take down the question. Take down the question. I will not live to the end. Who is still there with me? I will not live to the end. Who is still there with me? I will not live to the end. A water of mass 1.5 kg is heated from 30 degrees Celsius to 80 degrees Celsius using an electric kettle. Which is rated 5A 230V. Calculate the time taken to reach the final temperature. Calculate time taken to reach final temperature. Take specific capacity of water as 4,200 joules per kilogram per Kelvin. Take the specific capacity of water 4,200 joules per kilogram per Kelvin. A metal of mass 200 grams at a temperature of 100 degrees Celsius is placed in 100 grams of water at 25 degrees Celsius in a container of negligible heat. Of negligible heat capacity. Are you still there? Are you still there? If the final steady temperature is 30 degrees Celsius, calculate the specific capacity of the metal. Calculate the specific capacity of the metal. Calculate the specific capacity of the metal. Hope you have not left. I will not live to the end. I will not live to the end. Take 30 seconds to write, then we solve. Take 30 seconds to write, then we solve. Atinuke said, I will not live to the end. That's the energy. Mire Kwademo, I'm with you, sir. Omoumi said, yes, sir. Etim Lucia, well done. Caleb, well done. Miracle, Atinuke, yes. Limadon, well done, well done. Calorimeter is a device used to measure the quantity of heat lost or gained. Calorimeter, device used to measure the quantity of heat lost or gained during a physical or chemical process. Class, I want you to go to your physics textbook and go and study instruments and what they measure. What is used to measure atmospheric pressure, wind speed, wind vane, something like one question can come out from all of them, but it's worth it. Learn what used to measure everything, relative density, you know, pressure, everything, atmospheric pressure, normal pressure, everything, go and study, find this in your textbook. Instruments and their measurement, what they measure. Class, I want to know that we have the principle of heat loss equals to heat gained. Class, you can be told that water is placed into a calorimeter. There's water and there's calorimeter. And water is at a particular temperature. Inside the calorimeter, the temperature is hot. An object is now placed into the calorimeter and water. What will happen is that there will be a transfer of heat from the water and calorimeter to the object. There will be an heat loss from the water and calorimeter, there will be an heat gain from the object. Class, quantity of heat loss from the water is mass of water times specific capacity of water, because Q class is always equal to MC changing theta, right? What is changing theta? Theta 2 minus theta 1. So quantity of heat lost by the water is M, the mass of water, times specific capacity of water, times the change in temperature, plus mass of calorimeter, times the specific capacity of the calorimeter, times the change in temperature, will be equal to the mass of the object, MO, times specific capacity of the object, CO, times the change in temperature of the object, change theta O. I want you to understand they can give you a question like this, where you need to apply the principle of heat loss equals to heat gain. Where you need to apply the principle of heat loss equals to heat gain. Please take note of this formula. Heat is usually lost from the water and the calorimeter and usually gained by the object that is placed inside the calorimeter. It could be an object, it could be another liquid, it could be anything. Don't forget that the calorimeter helps us to measure the quantity of heat lost or gained during a physical or chemical process. Are we together? Class, anytime you hear the term latent, yes, latent means hidden heat. So they say latent heat of vaporization. It means the amount of heat that is what? The heat change that is what? That takes place that is not noticed. The non-observable heat change that takes place during the fusion or during the vaporization or during the whatever the process is. The latent means hidden heat. Class, when the substance changes temperature without any change in the, like when there's a substance what? There's heat transfer without any noticeable change in temperature. It's called latent heat. When there's no noticeable change in temperature, but there's heat transfer. Because normally for it to be transferred, it must be change in temperature. If you are 5 degrees Celsius, it should go to 10 degrees Celsius. But there's no noticeable change in temperature, it's latent. Latent means hidden. Please take note. Let's solve these questions and round up for today. Let's solve these questions and round up for today. The more we are together, the happier we shall be. The more we are together, the happier we shall be. 18 aluminum plate has a surface area of 1,500 meter cube at 20 degrees Celsius. What will be surface area A2 when it is cooled? Class, when it is cooled, expect the area to reduce. Class, when someone is cooled means temperature reduced. The temperature reduced to minus 20 degrees Celsius, so expect the area to also reduce. Class, they give us alpha. Class, can we use alpha for area? No. What's the term for area expansivity is beta. But beta is 2 times alpha, just like gamma is 3 times alpha. Class, learn this. They are always looking for ways to confuse you. Your examiner is always looking for ways to confuse you. Beta is 2 times alpha, gamma is 3 times alpha. I would advise you to watch this video again tomorrow morning. I might have been too fast in some areas. Need to calm down, reduce the speed and watch again. I always advise our students to watch every of our classes twice. The first one is just to flow. The second one is now for consolidation of knowledge. It's what we call consolidation of knowledge in neuroanatomy. Consolidation of knowledge in neuroanatomy. Class, if beta is 2 times alpha, what does that mean? That's 2 times 2.5 times 10 raised to minus 5. 2 times 2.5 is 5.0 times 10 raised to minus 5. That's our beta. A2, I've given you the formula for A2 before, is A1, right? Into bracket beta, change in theta, plus 1. This change in theta is theta 2 minus theta 1. What's my A1? 1,500. What's my beta 2? 5.0 times 10 raised to minus 5. What's my change in theta? Theta 2, which is minus 20, minus 20, which is minus 40. Theta 2 minus theta 1, minus 20, minus 20. Minus 20 minus 20 is minus 40. Plus 1. Class, normally something I do for my students. I usually like to test your mathematics knowledge. I will give you the final answer to this because in the Jamb, you'll be the one to multiply this by yourself. I shouldn't be helping you. Who can give me the final answer to this? I will write the final answer on the board of everything, A2. Check if you can do it by yourself and get this answer and put it on the board. Now, where's my question? Let me check what's the answer there. 18 aluminium, where are you? Class, your A2 should be 1497 meters squared. I want to see if you are able to get this. I want to see if you are able to land at 1497 meters squared. Let me test. If I am able to solve this in the Jamb, you really want to solve this by yourself. You really want to expand this bracket by yourself. If you cannot do it now, I'm not helping you. I'm not the one writing your Jamb. You are the one writing your Jamb. Let me give you 1 minute. Let me give you 1 minute. While I'm doing this, let me solve this. I don't have time. Let me solve this one. Or let me solve this last. Let me solve this. You can always watch the video again. Let me keep solving. Let me save your data for you. If I wait, I'm wasting your data. You can still rewind and check again, right? So let me be solving. You watch it, right? Class, note that any link, that the link I sent you that you used to join this class, is the same link you can use to watch it tomorrow. Don't come and ask me for, so where is the link of yesterday's class? No. That link I posted in the group this night that brought you here now. It's the same link I used to go and watch tomorrow. You can just click that link, save the link. The link I sent to you that brought you to this life, right? Use that same link to watch the class tomorrow. A water of mass 1.5 kg, mass of water 1.5 kg. It's heated from 30 degrees Celsius. Theta 1 is 30 degrees Celsius. Theta 2 is 80 degrees Celsius. Using an electric kettle which is rated class 5 ampere mains current. You see why exam is made from example. When I was teaching this topic, I did not mention current. I did not mention voltage class. That's what makes exam other than example. You can read the textbook, but when you go and see Jamb, you see another thing. That's why you should be close to your Jamb pass question this period. Don't just be reading only textbook. Be close to your Jamb pass question. There are some things that your textbook will not tell you until exam will just show it to confuse you. Exam was actually meant to confuse you. Look at, I've taught this topic now and I've not mentioned anything like ampere current. So we are going to use this question to learn something new, right? I intentionally chose every question I chose. Current is 5 ampere, voltage is 230 volts. Class, we have the heat loss equals to heat gain. Follow me. Heat loss equals to heat gain. Class, a water of mass 1.5 kg is heated from 30 degrees Celsius to 80 degrees Celsius. So the temperature of the water increased from 30 to 80. The temperature of the water increased from 30 to 80 means it gained heat, right? Using an electric kettle, it means that this electric kettle lost heat to the water. When you place water in the kettle lost heat, the water gained heat. So this is the side of heat gained. Quantity of heat gained is mass of water, but the water is the one that gained heat. The kettle is the one that lost heat. What's quantity of heat gain or loss? I've told you before. Mass times specific capacity of water times the change in temperature of water. Water changed from 30 degrees Celsius to 80 degrees Celsius. What is the heat lost by electric material? Class, note it is current times voltage times time. Take note. The heat lost by any electric material, whether it is kettle, electric, what's the electric? I current, V voltage, T time. Guess what? They asked us to find the time taken. Find the time taken. Meaning that every other thing has been given to us. What's our current? 5 ampere. I is 5. What's our voltage? 230. We are looking for time. These are our unknown. We don't know time. What's our mass? 1.5 kg. What's specific capacity of water? 4,200. What's the change in temperature? Theta 2, 80 minus 30, 50. So you see there is only time that is not known. Only time is not known. What I'm going to do? Make time subject of the 1.5 times 4,200 times 50 divided by 5 times 230, right? Make time subject of formula. Class, again, I will not help you to solve. I'll give you the final answer. I will not help you to solve. If I'm solving for you, I'm spoiling you. If I'm solving for you, I'm spoiling you. Let me check. What did they get? Let me check. What did they get? So I can tell you the final answer. One more question and we are done for the day. Where did I take that question from? So I can give you the final answer. Like I said, latent heat is the heat gained or lost without any change in the temperature of the body. Heat gained or lost without any change in the temperature of the body. Sir, I got it before you got it. Sir, I got it before you got it. 273.91 seconds. Who got this? 273.91 seconds. 273.91 seconds. 273.91 seconds. Who got this? Who got this? Let me solve the last question and call it a day. We have tried. Let me solve the last question and call it a day. It's not by how far, it's by how well. It's not by how far, it's by how well. It's not by how far, it's by how well. Let me solve the last question and call it a day. A metal of mass 200 grams. Class, anytime you see mass in gram, convert to kilogram immediately. Divide by 1000, convert to kilogram immediately, you have 0.2 kilogram. At the temperature of 100 degrees Celsius, initial temperature of water, 100 degrees Celsius. Is placed in 100 grams of water. Class, this mass of water 1, mass of water 2 is 100 grams. Convert to kilogram, divide by 1000. You have 0.1 kg. Please follow the story of the question. at 25 degrees Celsius. You see why it's good to do past question? Because you have solved this now. When you see something like this in Jamb, you don't have to read it 2 or 3 times because you understand the language of the examiner. Make sure you do your past question. Class, let me come again. A metal of mass, a metal. Oh, a metal, not water. A metal, mass of metal. A metal, mass of metal. Of mass 200 grams. Thank God I look at it again. A metal of mass 200 grams. So mass of the metal is 200 grams. Divide by 1000 to change to kilogram. 0.2 kilogram. At the temperature of 100 degrees Celsius, so 100 degrees Celsius, initial temperature of the metal. Mm means mass of metal. 200 grams change to kilogram divided by 1000. Temperature of 100 degrees Celsius is placed in 100 grams of water. So mass of water is 100 grams, change to kilogram. Initial temperature of water, let's call it at 25 degrees Celsius. In a container of negligible heat capacity, if the final steady temperature is θ3 is 30 degrees Celsius. What is specific heat capacity? What is the specific heat capacity of the metal? What is the specific heat capacity of the metal? Class, I think they forgot to give you something. Specific capacity of water is a constant. Please know whether you are giving or not. 4,200 joules per kilogram per Kelvin. Whether you are giving or not, know that specific heat capacity of water is 4,200. Please always remember that. Class, this is the principle of heat loss and heat gain again. Heat loss and heat gain. This is a simple principle of heat loss and heat gain. Tell me in the comments who is losing it, who is gaining it, if you are following me. Who lost it, who gained it? Class, I don't have time to check if you got it. Let me continue. The metal obviously lost it, class. Because this metal was 100 degrees Celsius. This water was 25 degrees Celsius. After the water was placed in the metal, check who lost it. The combined temperature is now 30 degrees Celsius. Two of them now 30 degrees Celsius. Meaning that 100 has gone to 30 and 25 has increased to 30. So the water gained it. When you want to solve this kind of question, you must establish who lost it and who gained it first. You must establish who lost it and who gained it first. The metal lost it and the water gained it. How do you know who lost it, class? Check the initial temperature of that person. If it reduced, he has lost it. But if it increased, he has gained it. Class, this metal was 100 degrees Celsius. And this water was 25 degrees Celsius. Before they came in contact with each other. After the water was placed in the metal, or the metal was placed in the water, anyone, their final temperature is now 30. Means that both of them now have a temperature of 30. 100 reduced to 30, 25 reduced to 30. Plus, heat lost by the metal, quantity of heat is mass times specific heat capacity times change in temperature of metal, right? Equals to mass times specific heat capacity times change in temperature of water. Quantity of heat loss equals quantity of heat gain. Law of conservation of energy. Energy is neither created nor destroyed, but can be transformed from one form to another. Heat loss equals to heat gain. Class, what's the mass of the metal? 0.2 kg. What's specific capacity of the metal? That's what we're looking for. Calculate specific heat capacity of the metal. That's what we're looking for. We don't know, let's call it Cm. Specific capacity of the metal. If I let's put all the M. The water. Change the temperature of the water, class. You're going to say 100 minus the higher temperature and the lower temperature. 100 minus 30. The final temperature is 30. Equals to what's mass of water? Mass of water is 0.1 kg. What's specific capacity of water? 4,200. What's change the temperature of water? Water move from 25 to 30. 30 minus 25 is 5. 30 minus 25. Class, always note higher temperature minus lower temperature. When you're dealing with heat loss and heat gain. When you're dealing with heat loss and heat gain, higher temperature minus lower temperature. Class, final answer. I want to see who can solve this math question. I will not go for it. I will not drop the final answer. Because in your Jamb, I can teach you, I've taught you the physics, the principle, I've taught you the principle. But class, to get Cm, it's no more physics, it's mathematics. If you cannot find Cm for me, there is a foundational problem there. If you cannot make Cm solve the formula here, there is a foundational. But it's now 0.2 times Cm, 100 minus 30 is 70. Equal to 0.1 times 4,200, 30 minus 25 is 5. Making Cm solve the formula, you have 0.1 times 4,200 times 5 divided by 0.2 times 70. And what is the specific capacity of the metal? If you do everything very well, you should have 150 joules per kilogram per Kelvin. If you got this, let me know. If you got this, let me know. Ladies and gentlemen, we are done and we have achieved our topics for today. I hope you have learned something. Don't forget to watch this video again tomorrow. Watch it again tomorrow. Don't relax. Watch it twice. Every video we do, watch twice so that you can have a proper understanding. Then go and take Jamb past question. Go and attack a lot of Jamb questions on this topic. Every day we are learning a topic. Look for questions on it and deal with every tougher question and even I took. Look for tougher ones. Understand the deal with it. You should have a material you are studying. Deal with it. I wish you all the best. Delete your TikTok. Delete your TikTok. Delete your TikTok. See you tomorrow, day 5. Day 5. We are making progress. Day 5. Don't forget I said that next week is biology, literature, and mathematics. Biology, for those of you biology, there's nobody that is doing biology and maths. So either you are doing biology or mathematics. Then literature is for art students. Commercial students are also doing mathematics. Commercial students are also doing maths. Good night, good night, good night. Thank you.